In this video, we learn about error management and the role of error boundaries in capturing and managing errors gracefully in React components. Specifically, we learn to implement error boundaries and use the getDerivedStateFromError and the componentDidCatch functions. Let's get started. When building React components, as with everything else, you're bound to come across errors. There are two major kinds of errors that you may face in a React app. Your components, especially the ones which involve side effects, may produce errors, such as when an API request fails to yield data. In such cases, a possible error due to a failing side effect is predictable and suitable error logging mechanisms can be designed from the get-go. For instance, components that fetch and display data from a resource, such as an API, can produce predictable errors if API requests fail. Therefore, a fallback UI can be built right in, and suitable error logging mechanisms can be built in easily. Predictable errors can be handled, but what about runtime errors? If a component produces a runtime error, it can produce unpredictable results, especially when local state is involved. Component crashes can in fact crash the entire application in the browser. These are the kind of errors that may be unpredictable but still need to be handled somehow. Otherwise, your users are in for a really bad user experience when an error occurs and you may never be able to easily reproduce it. This problem becomes even more complicated when you have a lot of nested components, each with the potential to throw errors at some point or the other. For instance, a hypothetical tree of components such as these poses a challenge when it comes to exception handling. If this component were to throw an error on account of missing data in a prop, then this entire app might crash, taking down local state and causing unpredictable errors and behavior. To prevent such a situation and to effectively capture and manage errors in a tree of components, React offers a feature known as error boundaries. Let's see error boundaries in action. As always, download and set up this project and bring up the development server. Our app has product category buttons at the top. Clicking these buttons displays products from the selected category as a list. Everything works well until I click on the routers button, in which case the app crashes and I get this screen because we are in development mode right now. In production, I would just get a blank screen and an error in the browser's console. The core app component itself is a function component which brings in data from an external file. This data is used to render the category buttons, and when these buttons are clicked, we get to render a list of products using instances of the product component. The product component itself is just a display component, which means that it just displays a product and its price. We are also using a function called title case here to format the product name in the title case, and this is where we seem to have an issue. Our database of products are coming from the getProducts file, which simply returns an array of products with a promise. Here's that array, and here's the reason why our app crashes. This property here should be called name and not names. This is a contrived error, but in reality there can be several reasons why an app might crash. Let's implement error boundaries to capture these unpredictable errors. In a fundamental sense, an error boundary is implemented as a class component. So let's build a class component which we'll name Error Manager. We'll first create a state property called error, which will be initially set to false. We want to use this as a switch to display a fallback UI when an error occurs. To turn this component into an error boundary component, we can implement two special methods that React provides. The first is the getDerivedStateFromError function, which is a static function. The static keyword simply means that this function can only be invoked on the original class and not on any instances of this class. In terms of React, this is a lifecycle function, which is called when a child component of the error boundary throws an error. At that time, the job of this function is to return an update to the state on the next render cycle, which can be used to display a fallback UI. This is why we are not using this .setState, but are simply returning an update to the error property. In the render method now, we can check to see the value of the error state property, and if it's true, we can render a fallback UI, which we'll do so in a moment. But if no errors are found, then we would want this error manager component to simply let the descendant hierarchy of components render as usual. This can be done by returning this.props.children, which is a special prop that lets React components access and render child components. Our fallback UI will display an image of a fail whale with a button to remove the error screen and go back to a stable version of the application. The reset button therefore will do two things. First, we'll reset the error property to false, which will remove the fallback UI and render the child tree of components as usual. Second, we'll run a function in a prop named onClose. We'll use this to reset the choice of category in our app component so that it goes back to a state where it was working correctly. We basically want to restore our app to a stable and working state. Now, we also get a second lifecycle method which we can optionally implement. This method is named component.didCatch and it runs after an error has been thrown by a child component. While the get derived state from error is used to update the state post an error, the component.didCatch function can be used to invoke loggers and other custom code that can be used to manage the error. This component gets two arguments, error and info. We'll only use the error argument here, which brings in the details of the error. This project contains a function named logger which simply prints a formatted error report on the console. In production, you might want to hook your error boundary to an external error logging service to get a report whenever your app crashes. Okay, let's export this component and we'll import it in our app.js file. Using our error manager component is amazingly simple. We'll just wrap everything inside this component like so. This will allow our error manager component to intercept any errors within its child component tree. Lastly, I'll set the onClose prop to run a function which resets my category selection like so. This means our app will display the default screen as you see on the right when the close button on the fallback UI is clicked. Now when I click on the routers function, I can momentarily see the fail whale UI before displaying the error screen again. The reason we see this elaborate error stack is because we are in development mode right now. I can remove this screen by clicking on this X button here and we can see our fallback UI in its full glory. Clicking on the close button here returns us to a stable version of the app. Now to really see how this app works in production, let's terminate our development server and I'll run npm run build. This will generate a production version of the application which removes error logging code in an effort to optimize the application for production. Once built, the production build will sit in the build folder. I've configured this project to serve the final app from this folder using a static web server. So once built, run npm run serve, which brings up a static web server serving the production app locally. Let's open this in the browser and I'll also open the browser's console. If I now click on the routers button, I can immediately see the fail whale UI. Clicking on the close button gets our app working again. On the console, you can see the output of our logger function here. As you saw in this example, a class component becomes an error boundary if it implements either get derived state from error or component did catch or both of these lifecycle methods. Once set up, an error boundary component can intercept runtime errors in the child component tree. But there's an important caveat here. At this time, error boundaries will not intercept errors in event handlers, async code such as side effects or callbacks, server-side rendered React code, and any errors that may be thrown within the error boundary component itself. Errors that occur in asynchronous code such as event handlers and callbacks would need to be handled using a standard try and catch block that can then update an error flag in the state. This can then be used to manually render a fallback UI. In effect, this is somewhat like the error boundary itself, but because the error boundary will not intercept these kind of errors, we can handle these manually instead. Error management is critically important when building React apps, and error boundaries go a long way in streamlining exception management.